So now we have a very, very, very interesting problem. On the left-hand side of the scale, I have two different types of unknown masses. One are these x masses, and we know that they have the same identical mass, and we'll call that identical, each of them have a mass of x. But then we have this blue thing, and that has a mass of y, which isn't necessarily going to be the same as a mass of x. But when I have two of these x's and a y, it seems like their total mass, or it definitely is the case, that their total mass balances out these 8 kilograms right over here. Each of these are 1 kilogram blocks. It balances them out. So the first question I'm going to ask you is, can you express this mathematically? Can you express what we're seeing here, the fact that this total mass balances out with this total mass? Can you express that mathematically? Well, let's just think about our total mass on this side. We have two masses of mass x, so those two are going to total at 2x. And then you have a mass of y. So then you're going to have another y. So the total mass on the left-hand side, and let me write it a little bit closer to the center, just so it doesn't get too spread out. On the left-hand side, I have 2x plus a mass of y. That's the total mass. The total mass on the left-hand side is 2x plus y. The total mass on the right-hand side is just 8. 1, 2, 3, 4, 5, 6, 7, 8. It is equal to 8. And since we see that the scale is balanced, this total mass must be equal to this total mass, so we can write an equal sign there. Now my question to you, is there anything we can do, just based on the information that we have here, to solve for either the mass x or for the mass y? Is there anything that we can do? Well, the simple answer is, just with this information here, there is actually very little. You might say, well, let me take a y from both sides. You might take this y block up. But if you take this y block up, you have to take away y from this side, and you don't know what y is. And if you think about it algebraically, you might get rid of the y here, subtracting y, but then you're going to have to subtract y from this side too. So you're not going to get rid of the y. Same thing with the x's. You actually don't have enough information. Y depends on what x is, and x depends on what y is. Lucky for us, however, we do have some more of these blocks laying around. And what we do is we take one of these x blocks and I stick it over here. And I also take one of the y blocks and I stick them over here. And I stick it right over there. And then I keep adding of these ones until I balance this thing out. So I keep adding these ones. So obviously if I just place this will go down, and because there's nothing on that side. But I keep adding these blocks. I keep adding these blocks until it all balances out. Until it all balances out. And I find that my scale balances once I have 5 kilograms on the right-hand side. So once again, let me ask you this information, that now having an x and a y on the left-hand side and a 5 kilograms on the right-hand side, and that fact that they're balanced, how can we represent that mathematically? Well, our total mass on the left-hand side is x plus y, x plus y, and our total mass on the, let me write that once again a little bit closer to the center. It is x plus y on the left-hand side, and then on the right-hand side I have 5 kilograms. I have 5 kilograms. I have 5 kilograms on the right-hand side, and we know this is what actually balanced the scale, so these total masses must be equal to each other. And this information by itself, once again, there's nothing I can do with it. I don't know what x and y are. I can, if y is 4, maybe x is 1. Maybe x is 4, y is 1. Who knows what these are? The interesting thing is, we can actually use both of this information to figure out what x and y actually is. And I'll give you a few seconds to think about how we can approach this situation. Well, think about it this way. We know that x plus y is equal to 5. So if we were to get rid of an x and a y on this side, on the left-hand side of the equation, what would we have to get rid of on the right-hand side of the if we get rid of an x and a y on the left-hand side of the scale, what would we have to get rid of the right-hand side of the scale to take away the same mass? Well, if we take away an x and a y on the left-hand side, we know that an x plus a y is 5 kilograms. So we would just have to take 5 kilograms from the right-hand side. So let's think about what that would do. Well, then I would just have an x left over here, and I would just have some of these masses left over there, and I would know what x is. And let's think about how we can represent that algebraically. Essentially, if we're taking an x and a y from the left-hand side, if I'm taking an x and a y from the left-hand side, I'm subtracting an x, I'm subtracting an x, and I am subtracting, actually let me think of it this way. I am subtracting an x, I am subtracting an x plus y. I'm subtracting an x and a y from the left-hand side. But then what am I going to have to do on the right-hand side? Well, an x and a y we know has a mass of 5. So we can subtract 5 from the right-hand side. And the only way I'm able to do this is because of the information that we got from the second scale. And so I can take away 5. So this is going to be equal to taking away 5. Taking away an x and a y is the same thing as taking away 5. And we know that because an x and a y is equal to 5 kilograms. And so if we take away an x and a y on the left-hand side, what are we left with? Well, this is going to be the same thing. Let me rewrite this part. This taking away an x and a y is the same thing if you distribute the negative sign as taking away an x, and taking away a y, and taking away a y. And so on the left-hand side, we are left with just 2x, and we take away one of the x's. We're left with just an x. And we had a y, and we took away one of the y's, so we're left with no y's left. And we see that here visually. We have just an x here. And what do we have on the right-hand side? We had 8, and we knew that an x and a y is equal to 5, so we took away 5, and so to keep the scale balanced. And so 8 minus 5 is going to be 3. 8 minus 5 is equal to 3. And just like that, using this extra information, we were able to figure out that the mass of x is equal to 3. Now, one final question. We were able to figure out what the mass of x is, but can you now figure out what the mass of y is? Well, we can go back to either one of these scales, but it'll probably be simpler to go back to this one. We know that the mass of x plus the mass of y is equal to 5. So you could say, so one thing we know that x is now equal to 3. We know that this is now a 3 kilogram mass. We can rewrite this as 3 plus y. 3 plus y is equal to 5. Well, now we say, well, we could take 3 away from both sides. If I take 3 away from the left-hand side, I just have to take 3 away from the right-hand side to keep my scale balanced. And I'll be left with that the mass of y is balanced with a mass of 2, or y is equal to 2. That's analogous to taking 3 from both sides of this equation. And on the left-hand side, I'm just left with a y. And on the right-hand side, I am just left with a 2. So x is equal to 3 kilograms and y is equal to 2 kilograms. And what I encourage you to do is verify that it made sense right up here. Figure out what the total mass on the left hand and the right hand, or verify what the total mass right over here really was 8 to begin with. And you see that 2 x's are going to be 6 kilograms, plus my y is 2 kilograms. That will balance 8 kilograms. And 3 plus 2 was equal to 5.